So today, guys, what's left for us to do in three-dimensional shapes is cylinders. So those are the three-dimensional shapes which have circles as bases. Now, if you were at the exam boot camp, you know we already dealt with cylinders. We spoke about them because one of our questions had to do with cylinders. Okay, so in order to calculate the surface area of a cylinder, you need to know what shapes make up the surfaces. Okay, because that's what surface area is all about. We're going to work out the areas of the different surfaces and then add it at the end to get the total surface area of your three-dimensional shape. So obviously, the top and the bottom of your cylinder will be circles. Okay, they can be made up of the same circle at the top and at the bottom. And now we speak about the curved part in the middle, which is usually the big problem when it comes to surface area of cylinders. But if you take that middle part, as we are doing over here, this middle part, let's say you cut a line, a straight line right down, and you unroll it, then you can see that it actually makes up a rectangle. So to work out the surface area, or the area rather, of this middle part, we are going to use the formula of a rectangle, area of a rectangle. Now, in order for us to use the area of a rectangle, we need to know what the dimensions of that rectangle are. Okay, now this part I know you guys can get pretty soon and quick and easily, right? The breadth of your rectangle is the same as the height of the cylinder, right? So if I say my cylinder going all the way from there to there is 10 meters, then your breadth will be 10 meters because it's just going from the top of the shape all the way down. Now the length is a little bit more complicated, right? Do you guys agree that this whole side of my rectangle was wrapped around the circle? Do we see that? That side of the rectangle was wrapped around my circle. That means that my length is the same as the perimeter or the circumference or the outside of the circle. That's how we end up using 2 pi radius. Does that make sense, guys? Can I get a thumbs up on that? The length of the rectangle that you now have is the circumference of your circle because it went all the way around the circle on the outside. I only got 3 thumbs up, so I don't know. Everyone else, are we not with me? Is there something you want me to clarify on that? Lorianne is not with me. Lorianne, do you mind unmuting so we can speak about it?
I just don't understand. Like, I was kind of lost for a second about the circumference of the circle.
Okay, so look here, Lorianne. So we said the middle part can be unrolled into a rectangle. You're with me on that part, right?
Yeah.
But before you unroll it, this whole length part of the rectangle was wrapped around the outside of your circle. Does that make sense?
Mm-hmm.
Yes.
That means to find how long the side is, we need to know how long it is going all the way around the circle. And that's just your circumference.
Ma'am, ma'am,
Yes.
can you please repeat what you said?
I'm saying because this was wrapped around the outside of your circle, this is your circumference or the perimeter. Think of it as wrapping the outside of your circle. Okay.
Oh.
So if you, let's say this is the outside of your circle and I were to unwrap it, it creates sort of a straight shape. But in order for me to know how long that is, I need to work out the outside, which is the circumference. This is the same as perimeter of your circle.
So the top side and the bottom side is the areas.
The
Wait,
areas is
or
for
is
the
there a base and
inside.
an area?
The area will work out the circle parts. Does that make
Oh,
sense?
okay, okay.
So we use formula of area for the circle parts of this shape, but the formula for circumference only tells you the length of this rectangle. Does that make
Oh,
sense?
oh yeah, now I understand.
Wonderful, wonderful. Thanks for asking, guys. I had a 2-for-1 special. I love it when people unmute. I love it. Okay, so hopefully you guys are with me. So let's do an example to explain what I was talking about here. Okay, we'll go back to the formula just now when we all got it. I'm going to insert a radius here. They've given us a radius, but I'm just going to put it there so that you know where that guy comes from. This is the radius, right? From the middle of your circle to the end. And we have been told that this is 4 meters, right? Now I want the surface area of this shape. How many circles do we have in the cylinder? How many circles do I have in the cylinder? Let's hear what we have to say. Is my chat working? Yes, it is. We have 2 circles, right? There's one at the top, and we know there's another circle here at the bottom. We don't see it, but it's there. Okay, usually they draw something like that to show you that there's another circle at the bottom. So that means we're going to say, okay, let me say area of the circles. That means you have pi times radius squared times 2. Are we with me, guys? So this is because there are 2 circles. There's one at the top and one at the bottom, right? And the second part is just the formula for the area of a circle. For area. Now I can do this because the circle at the top is exactly the same as the one at the bottom. Do you see what I mean, guys? So let's work that out for this specific one. That means it will be 2 times, let's use pi as 3,14 again. So it's 2 times pi, which is 3,14, times your radius squared. Okay, let's get working. I also have my calculator, not really. It's my cell phone, but yeah, you get what I mean. Calculator, cell phone, 609, same thing. Let's get working out. I'm going to need to compare my answers with someone else, so I hope you guys are also working out. Okay, I have an answer. You guys will tell me when you have an answer. Thank you, Seth. I got the same thing. 100,48 meters squared because it's an area. Okay, so this accounts for your 2 circles. Now, the area of the middle part, while we're still getting used to it, I'm going to actually draw a rectangle. Okay, I'm going to actually draw the rectangle. So just imagine this rectangle is the one that was wrapped around my shape. Are we with me? Now, I want you guys to tell me this shorter side of this rectangle. How long is that side? How long is the shorter side of your rectangle, or your breadth or width of the rectangle? What do you think, guys? I know it's going to take a while, but just pretend I actually had something that I could have. Never mind. It's okay. How long is the width? What do you think, guys? By width, I mean this side over here. Okay, we need to visualize these shapes, okay? Remember, Ronnie, the 4 has nothing to do with the middle parts. Do you guys agree with me? The 4 is the radius for your circle. So it's all the way over here. It's measuring from there to there. That's the 4. You get it? But how long is this one? There we go. So we know that this side is 8 meters because this side was the height of my shape. So imagine you took scissors and you went and cut it all the way that way. That means this side will be the 8 meters. Okay. And now we know that this part, this is what we were talking about, was wrapped around the circle. Now, what's the word for going around the shape? What do we call that? Area is if we are in the middle of the shape, but what's the word for when we are on the outside or around the shape? Perimeter, or in circles specifically, what's the word we use? The one specifically, not volume, for the outside of the shape. Think about it, guys. Circumference. Thank you. It's the circumference, right? And how do we work out the outside of the shape? What's the formula for the circumference of a circle? Does anybody remember? What is the formula for the outside of a circle? We need to learn our formulas, guys. Yes, 2 times the pi times the radius. Now, I need to clarify something here, okay? This 2 was there because we had 2 circles. You're with me? This 2 is part of the formula. If you look at the formula for the outside of a circle, the formula is 2 pi r. Okay, so we know that the length of this rectangle is 2 times pi times radius. So let's work out the lengths. 2 times 3,14 times the radius, which was 4. Let's get working out with that one. 2 times 3,14 times 4. Okay, I have an answer. Let's hear what you guys have to say. What do we have to say with this one? 25, 1, 2. And this is just in meters because this is not your area. Okay, you need to be very careful. This is not your area. This is the side. So this side is 25,12 meters. Then you can say area is length times breadth, which is the 25,12 times the 8. And that gives us how much? Let's see. Times 8. The 25,12 times 8, and that gives us, I got 200,96. Please confirm for me. Thank you. 96, and this is in meters squared. Now to get your total surface area, you say the area of the 2 circles, which was 100,48, plus the area of the middle part, which is 200,96, and that gives us plus 100,48. That is 301,44 meters squared. Whew. Okay, I know there might be someone who's still confused about this, and that's okay. Can I get a thumbs up, thumbs down on this whole question? Botlhale is even celebrating. And Lenomta. I need you to be 100% sure. Don't just put a thumbs up there if you're not sure, okay? Lorianne, let me unmute you. There we go. Hello.
I'm really lost. So the length of the What is that? The rectangle. Now, I understand that part, but the area in the top surface area, I don't understand that. I don't understand how you got that.
Okay. Lorian, can you give me 2 seconds to do something? I'm going to be back, ne? I have
Okay.
something that's going to help me answer this question with you. Just give me 2 minutes. I'm coming back. Okay, I'm back. I'm going to do a show and tell. Lorian, are you there?
Yep.
Okay. So, Lorian, say I'm going to give someone this, okay? Just use your
Okay.
imagination. A cylinder, right?
Okay.
Now, total surface area means I want to cover this thing, which means I'm going to have to put a cover over this part, and then I must cover the top, and I must cover the bottom. You with me?
Yes.
So the first part of this thing is, let me highlight it for us, is the area of the circles, because there are two circles. We're going to have a circle at the bottom that we need to cover, and we have another circle at the top that we need to cover. You're with me?
Yep.
So then we worked out the area of that. And we know that the area of both the circles is 100,48. We're good.
Okay.
Now I'm going to cover the sides. And I'm going to cover it that way. Do you agree with me?
Mm-hmm.
Right? Now, if you take off this round thing, you can see it gives us a rectangle. So we got our rectangle. And to find out the length, we need to know the circumference of this thing because it's going to go all the way around, which we did. We found the length. And then this is just the height of your object. So because this is a rectangle, right?
Mm-hmm.
How do you work out the area of a rectangle?
I'm not sure. That's
Length
what I'm understand.
times
Length
breadth.
times breadth.
Okay. And we just established that your length, or the longest side, this one, is the one that goes around. So that's why we worked it out using the circumference. Does that make sense?
Yep.
And then your breadth will just be the height of the shape. So you times them, you get 200,96. Now, if
Mm-hmm.
you are going to buy wrapping paper for this thing, if you bought 200 meters squared, would that be enough to wrap the whole thing?
No.
No, because you didn't take into account the 100 for the two circles. So that's why we had to do that means in total, I'm going to need 100 meters squared for the two circles plus the 200 meters squared for my around. And that's why your total surface area ends up being 301,44.
Oh, wait, now I understand. Okay, wait.
Um,
Okay. Thank you.
you're welcome. Okay. So my teacher teached us, okay, the method we got at school is 2 pi r squared plus 2 pi rh. That's where I was going, Seth. I just needed to know everyone to understand where that formula comes from. Okay, that's exactly what we have over here. So the surface, it's actually surface area, will be this. The let's bisect where this comes from, or dissect it rather. This comes from the two circles. We said that, right? This 2 is because there are two circles. And then this is formula for area of a circle. So 2 times the formula of the area of a circle. And then we move on to here, right? 2 pi r is your length of this rectangle. And the h is your breadth of this rectangle. Does that make sense, Seth? So yes, that is the formula, but you guys, I think you guys should just know where it comes from. Thumbs up, thumbs down on this formula. Excuse me. Woo. So yes, it's good to know the formula, but it's also good to know what that formula means. Because in true nature of teachers, we're going to start removing parts from that cylinder. Right? So you must know, if I took off the circle at the top, how would that affect my formula? Do you see why I like explaining them? If I took off the top part, then we don't need this 2 because there's only one circle. So you would just say pi r squared. You see what I mean, guys? So I want you guys to know where this formula comes from, or these formulae come from, because when we start manipulating it and changing it, then you need to know. Okay, like the next question. Of course, I wasn't going to disappoint you guys. A cylindrical plastic straw. What do we know about a straw? Why is
That you
it going
take out
to
of it.
mess up our formula? What do we know? Yes, Lorianne?
No, sorry.
What do we know about the straw, guys, that's going to mess up this whole formula? Let's hear what you guys know. Anybody? Can we use the formula as it is to work out this? Can we use the formula as it is? Why not, Seth and Botlale? Why can't we use the formula that we were given as it is? Let me rewrite it maybe. Nah? Let me rewrite it. It's so surface area is 2 pi r squared plus 2 pi r h. Not the diameter. That's not the problem here. Look at my formula. We're going back to the formula, right? Right? I'm going to ask you guys this time. What does this part account for in a cylinder? What does that part account for in the cylinder? Look at your formula. The pi r square part, the 2 pi r squared. What does that account for in the formula? It's not the radius. Listen to my question, guys. What does the 2 pi r squared account for? Nice, Leah. Do we have bases in a straw? Do we have circle bases in a straw? You all know what a straw looks like. Is there a base in a straw? No. Why not? Why would there not be a base in the straw? Dumi says yes. Okay. I want to hear from Andile why Andile says no, there's no base in a straw. What do you say? This is worth a lot of marks in a test, right? So I want to walk you guys through it so we can talk about what it means. Why am I not going to calculate the area of the circles, guys? How does a straw look? There are no circles. Thank you, Andile. In order for a straw to be functional, there can't be circles blocking the ends. Do you guys agree? The 2 ends don't have circles on them. It's open, it's hollow. Does that make sense? Guys, can I get a thumbs up on that? You're very quiet, so I'm feeling like you guys are not getting what I mean. Think of an ordinary straw you would have seen anywhere. You just cannot include the circles because there are no circles in a straw. Basically, it's just the outside of the straw. Okay, so this part that accounts for the circles, will we be using it in this specific example? The base is not 7. That 7 is your diameter. It's showing you that the diameter of that little baby circle is 7 millimeters. Does that make sense, Leah? That's not the base. Yes, there we go. That's the diameter of the little baby circle. All right, so we're not going to use this part because there are no circles. You're not going to close your straw off on both ends, are you? Because then how are you going to use it? You can't use it. So the only part you use is the wrapping around, which make the straw. And we have established that that wrapping around is a rectangle. So imagine you're taking this and you're going to fold it over into a straw. Does that make sense, guys? You're folding it over into a straw. So then I want to know, this long side, how long is that? The length of your straw, how long would that be? 21 centimeters. You just unfolded it, okay? So it is 21 centimeters, okay? Now this part, do we all still agree that this part is the one that goes into a round circle? Are we with me still on that? Yes. Is it 7 millimeters? No. You need to work out the circumference. Okay. Now, the 7 millimeters is your diameter. Do we guys agree? Radius. Okay. So what's my radius of this little circle? Wandile, what do you mean? Let me first answer Wandile. I don't want anybody to get lost. I know it is very tricky. I'm actually going to open this to make my point of the straw. This is hollow, so there is no circle there. So if you're working out the surface area of this, you don't need the circle, okay? How is it not 7 millimeters? So look here, Wandile. Do you see this little cylinder, whatever I got here, the lid? You see it? Right? That's 7 millimeters, Wandile, is the diameter of your circle. So going from the top to the bottom of your circle. Are you with me? Is that the same as the length going from there all the way around to there? I'll be with you just now, Leah. Is it the same, Wandile? Does the length going through from the top here right to the bottom equal going all the way around here? Exactly, we don't know. So you cannot say that this length is the same as going around. That 7 is from the top to the bottom, from there to there, not going around, just straight down. Does that make sense? Okay, I feel like you're with me now. Wonderful. Someone else had their hand up. Where did the hand go? There we go. Leah, do you want to unmute or do you want to type in the chat? You can unmute if you want.
Hello, ma'am.
Hello.
You see where the 7 meters were, right?
Yes.
You unwrapped it. Is this, are we still calculating the 7 meters?
That 7 meters was only telling you the diameter of this circle. Do you see?
Yes, ma'am.
Which we need to work out the circumference. I know it's confusing because there isn't actually a circle there, but the only way to work out the perimeter of the circle, the outside, We need that 7 millimeters. Are you with me?
Yes, ma'am. Thank you.
You're welcome. Okay, I'm glad you guys are asking questions. I know as soon as we hollow these out, it doesn't make sense. You might be thinking, why do we need that 7 millimeters if there isn't a circle there? We need it because that's the only way we can get your outside, which is the circumference, which is what we are looking for. Okay, guys. So my radius will then be half of 7 because your diameter is twice the radius. Okay, which is 7 divided by 2. That means it'll be 3.5 millimeters. Before I even jump here, there's actually a lot to do here. Okay, let me rewrite it properly. So your radius is diameter divided by 2, which is 3.5 millimeters. But I saw you guys said it earlier in the chat. These two guys are not in the same units. Okay, so how do we go from millimeters to centimeters? Let's see if we've been revising our conversions. How do we go from millimeters to centimeters? Think of your ruler. Your ruler has both millimeters and centimeters. This should be the easiest conversion. Divide by 10. Wonderful. Okay. So 3.5 millimeters. One delay, remember that's when we go from meters. Okay. Meters. But now we're going from centimeters. Divide by 10. And this is equal to 0.35. Whew, centimeters. Now we can say that means the surface area. Do you agree? Nope, I've jumped the gun here. Okay, circumference, 2 pi radius. That'll be 2 times our pi, which is 3.14, times the radius, which is 0.35. Let's find the circumference, which tells you the outside of the circle, which is going to tell you the breadth of this little rectangle. That little small side, 2.198. Okay. 2.198 centimeters. Now we can say, well, then the surface area is equal to, what shape is this, guys, on the side that we've been working with this whole time? What shape is that? A rectangle, right? So then the area is just length times breadth, which means it'll be that 2.198 times 21. And let's work out our surface area. Times 21. 46.158 centimeters squared. Are we done answering this question? Let's see if someone actually read the question. Are we done answering this question? What's left, Bukhali? Bukhali is the only one who responded. What's left with answering this question? What do we still have to do? Ha! This was for one straw. But they just told us we need 100 of them. So what will I do with the surface area that I have now just calculated? What will I do with that surface area? Because this guy, yes, Butlali, this is only for one straw. Okay, so then for 100, you will say the 46,158 times 100, which is, we don't even need our calculators for this, 4,615,8 centimeters squared. What a question. Can I have a thumbs up, thumbs down on this whole thing? If there's one part you're not sure about, do not give me thumbs up. Okay? Speak up. Only 2 thumbs up. Okay, 3. 3 now. 4. Come, there's like 13 of you in here. I'm expecting to see more. Lorianne, if you have a question, you can unmute.
I'm a little lost by the surface area once again.
By this part. Do you mean
Yeah.
here? Okay, so once we have gotten all of our dimensions, right? Do you agree? Yes, I understand this was wrapped around and, I mean, there's a rectangle. You with me? But if I do this to it, it's a cylinder, right? But now we're working with it unwrapped and we want to know what the surface area is. So I want to know the area of this whole part. So then I asked, well, then how would we work out the area of that part? We just work it out like we would a normal rectangle. So that's why I said, well, then the surface area is just length times breadth because that's all you have, right? You have a rectangle. And that's how I got my length, which was 21, and my breadth that we worked out over here. And that's how I got it. Does that make sense?
Yes, it does. Thank you.
You're welcome. Okay, guys. And then all I did after that was times by 100 because we needed 100 straws. The reason we don't have the 2 circles here is because it's a straw. There's no circle at the top and there's no circle at the bottom. Okay, guys. Have we all taken our screenshots? Screenshotters, are we good? Wonderful. Now, I like leaving volume for last because volume is much simpler, right? For volume, remember I said area of the base times height. Do you see this keeps coming up in every shape that we're doing? What is my base in this case? Area of the base times height. What shape is my base in this case? What shape is my base in this case? Anybody there?
3 centimeters.
But what shape is it? What shape is it?
The circle.
It's a circle. That's it, right? So then your volume will be the formula for the area of a circle, which is pi times radius squared times the height of your shape. And that's it, guys. Now you substitute.
So, sorry, ma'am. So, does that stand for, what does the V stand for volume?
Yes. V is
So
for
then the height will be 12 centimeters, right?
yes.
Okay.
Times 12. And that's it. Do you see why I leave volume for last? Because we usually do it very quickly. We're done. After this is your answer, guys, and we're done. Times 3 times 3 times 12. Okay, I have an answer. Let's hear. There we go. Now, centimeters. What exponent goes there with my centimeters for volume? Cubed. Nice, Butlali. Cubed. And that's it, guys. Thumbs up, thumbs down on volume of a cylinder. Was that
This
not
is actually the easiest one I've done so far.
exactly? This is why I make volume last, because surface area dribbles all of us. So when we're tired, it's easy to do volume. That's why I said, guys, as long as any prism I hope you guys know the difference between a pyramid and a prism.
I have a question, ma'am. So, the reason why it's centimeters squared to 3 is because the radius is 3.
No, it's because you're multiplying units 3 times. So look at this, right? 3,14 is a constant. You agree with me? It doesn't change. But this 3 was not just 3, it was 3 what? Centimeters, right? So you're
Yep.
multiplying a 3 centimeters with another 3 centimeters. That's what the square is. But the 12 was also in
4. Okay.
centimeters. So how many centimeters do you have here? 1, 2, 3. And
3.
that's how you end up with centimeters cubed.
Oh.
Makes sense?
Yep.
Okay. Wonderful. Okay, guys, remember surface area is always squared because there's only 2 dimensions you're actually substituting here. My English for a moment was like, bye. So here it was 1 centimeter and another centimeters, which is why you end up with 2 at the end. But for volume, you have 3, so it is centimeters cubed. Okay. I think I'm going to give you guys a brain break first. Who's going to talk to me for the brain break before I start the hectic stuff? I know the new people, you're not used to a brain break. We haven't done it in a while. I'm just going to give you guys some puzzles to solve. Is there anybody who wants to take part in today's brain break? And it's not would you rather for once, guys. It's not would you rather. Linamta, are you ready? I have a new one. Aha. I have a new one. I see Elam is also back and ready. Elam used to love brain breaks. So let's see. Let's not disappoint here. Ne? Okay. So you need to guess the phrase or the word based on the picture. Now let's look at the first one. What would you guys say that is? Maybe I should allow you to unmute in case someone actually gets the answer.
Please don't videotape what I'm going to say, okay?
1 million.
Nope.
The companies take that back.
It's a phrase. Do people just go around saying 1 million, guys? It's not million. If people want to say you're really unique, yes, Leah, you are 1 in a million. Boo, 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 boo. Okay, now that you guys know how it works. Are you ready for more? Okay, let's see the next one. Oh. And when you see it, almost, but you guys are not quite there. It's not 8 eggs. Think of eggs. What's wrong with the word eggs there? What's going on, guys? Not chicken. What's going on with the word eggs there? Scrambled eggs. Oh, funny, got it. Boo, 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 boo. Are you ready for the last one, guys? I'm only gonna do 3 with you guys. Otherwise, we're gonna be here forever. Okay, what's going on? Andile's hand is up. Andile, do you want to unmute?
Ma'am, the answer is I fell down.
No. You're close. You're so close. I thought you were about to say the answer.
I got it, but it's gone. I fell 700 times.
Nope. Guys, who says I fell 7 times just randomly on everyday conversation? Look at the shape. that those Eiffels are making. I gave you such a big clue just now. Look at the shape. Why is it getting narrower as it goes to the top? What does that look like? Ha! Elam, almost. Someone is going to steal the answer from you because of that. Someone is going to steal the answer from you. Guys, Elam is the closest person. Closest person. Put together what you've been saying. There we go, Andy. That's the Eiffel Tower. Boo, 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 boo. There we go. Okay, our brains took a little bit of a break. It's been a while since I had brain breaks. Woo! Okay, let's do a little bit of the question that is going to make us feel like we have earned this brain break. Okay, a cylindrical drinking glass. So this is a glass, okay? How does a glass look like, guys? At the top, does it have a circle at the top? No. So we know it's open at the top, right? There is no circle over here. Okay. Made up of a solid base and a curved top part which is hollow and open. Solid base means this is all glass. Have you guys seen glasses like that? Where they have like a little bit at the bottom that is just glass, like thick glass, and then the open space starts. Are we with me? Calculate the total volume of the drinking glass. Now I'm going to be warning you quickly here. What's the trick here, guys, when calculating volume of this glass? I want to know how much liquid I can fill into this glass. What's the trick here? There is a trick. I want to see if you guys can see what it is. What's the trick? Okay, not quite, but let's convert that. Let's convert that. It has something to do with it. Okay, it has something to do with it. Again, 15 millimeters to centimeters. That's going to give us 1,5 centimeters. Great. Total volume. Okay. Now I'm going to give you a clue here. That 7 is this whole part that I just highlighted yellow. Does water go in the bottom part of that glass? So can you work out volume using the whole 7? So we need to figure out the actual height of where we're going to use, right? And how are we going to do that, guys? How are we going to do that? Because the water can't go into the bottom part that's solid glass. Do you guys agree with me? So then the actual height here that we're going to use, which is from here to there, is going to be 7 minus the 1,5, and that gives me 5,5 centimeters. That's the only trick with the first question. So then volume is the area of base times the height. What's my base? It's a circle. So that's pi times radius squared times your height. 3,14. What's the radius here, guys? I'm going to wait for you guys to tell me the radius while I fill this down. What's the radius for this glass? It's not one, it's 3,5. Yes, 3,5. A lot happened there in 2 seconds squared. Okay, so let's work out the actual volume of this glass. I have my calculator out also. Times so your volume, I got a different answer. Let me check again. Times oh, I don't know what I did. Now I got your answer. 211,56 centimeters cubed. And to convert to milliliters, let's see if you guys remember how to convert to milliliters quickly. How do you go from centimeters cubed to milliliters? It's the easiest conversion in the history of conversions. Thank you very much, sis. It's the same thing. It's 211,56 milliliters.